All right, hey, today we want to work on a little circuit here. It's a LED chaser. Essentially, in this circuit, the lights chase after each other, and they function by way of this 4017 IC chip, which is a 16 pin DIP chip. Essentially, it's a decade counter. It counts in multiples of 5. And we're going to drive it with a 555 IC chip, which is a timer. We're going to let this provide the clocking. So every time it gets a pulse from this 555 timer, the 4017 would change state and move on to the next output pin. So we're going to essentially put that together today. But I'm just going to go over the circuit a little bit. The 555 timer chip is going to be set up to operate in astable mode. That means it's going to re-trigger itself. We're using 1000 ohm resistors between pins 6 and 7 and 7 and 8. Pins 2 and 6 is connected. We're going to be using a capacitor, 100 microfarad capacitor for this. Pin 3 is going to be your output. That's going to be your clock pulse. That's going to drive the 4017 at pin 14. This circuit, both circuits are going to operate off the 5 volt supply at the same time. The LEDs going to have current limiting resistors of 100 ohms each. So each one of these LEDs that are here on the cathode side of it, I'm going to put 100 ohm resistors on each pin, and then that's going to go to our grounding line, which is here. It's going to be our grounding area, and then the anode side are going to come off the chip itself. So let's say this was the pin. The anode side will connect to that pin and go to the negative ground through a current limiting resistor of 100 ohms. Pins of this circuit, pins 8, 15, and 13 are going to go to ground as well. Pin 16 is going to be your positive pin. And this, like I said, this chip has 16 pins, and as you notice, the notch right off to the left of the notch is pin 1. So you got 1, 2, 3, 4, 5, 6, 7, 8, and we continue around this way. 9, 10, 11, 12, 13, 14, 15, and 16. And pin 16 is also going to a positive rail. Then pin 14, which is, I think that's this one, see, 9, 10, 11, 12, 13, 14. Pin 14 is going to get the clock pulse from the IC 555 chip as shown here. So we're going to break out the breadboard. I've already added the LEDs to the breadboard and the resistors, and we will show you that now. Let me just move these off to the side. Okay, here we are. We have some of the fun stuff already out the way because it's so time consuming. I want to bring you in a little closer with the lighting, with the zooming if I can. See if I can bring that down just a little bit more. There we go. And so what we're going to do now, I have the LEDs. These are the current limiting resistors. As you can see there, they're all 100 ohm, brown, black, brown. And they've already been placed in on the cathode side of the LED. So this is the cathode side of the LED, and this is going to go to the all the pins from this side of the resistor are going to feed into the pins of the IC, which I'm going to plug in right now. All right, I'm going to plug in the 4017 first. We just put that into the breadboard, and we just plug it in like so. I got pin 1 is going to be on that side. I'm also going to place the 555 timer chip as well into the breadboard. And pin 1 is off to the left of that dot. This one don't have a cutout like this one, but we know that if it has a dot, that's pin 1. Okay, so we're going to commence wiring it up. I'm going to hook up the 555 timer circuit first as an astable mode circuit. So I'm going to put pins 4 and 8 together now. I'm going to put pins 4 and 8. We're just going to tie those together. And I'm going to put pins 2 and 6 together. Pins 2 and 6. As you see, we got 1, 2, 3, 4, 5, 6. So pins 2 and 6 together, 4 and 8 together. I'm going to be using this side of the rail too, so I'm gonna make sure that these positive line also feeds this track as well. I'm just going to do that with some jumpers. I'm going to take from our negative rail here. I'm just going to run it over to the negative rail on this side because it doesn't have a way of getting juice over here on this side. So I'm just going to run something over there. I'm also do the same thing with the positive side. So I'm going to put the positive rail feed onto this rail now. Now this rail is negative and positive. Also, this one is negative and positive, and they're both getting energy. Going to get energy. The LEDs on this side are already tied into the negative rail. So all my cathodes are into the negative rail already, as you can see, and the anodes are going to get the resistor parts. So now we're going to hook up some hookup wire, and we're going to try to follow the wiring diagram here. So I'm going to try to put that in front here so we can see how we're doing that at the same time, right above that. Okay, so I'm going to use try to use one color for all these. It's going to be 10 wires, so I got to try to use one color for each one. Let me see if I can do something about the focus here. It's not like I like it. I guess that's going to have to do. All right, so let's get started. We're going to do pin 3 of the chip, which is this was a 1, 2, 3, and that's going to go to the first LED that I want to light up. I might start here, as this might be the row. Start off the LED bank from as 1, or I might make this one. I think I'll make this one as the first one to fire. So this is going to be the first one to go off. Then when it gets another pulse, we're going to get a feed from pin 2, and that's going to feed IC number 2, or LED number 2, I'm sorry. Then from pins 4, that's going to feed our third LED. And I'm hooking these up where, you know, as this resistor has 2 wires, the first wire is running to the should be running to the circuit of the thing here. So I'm gonna put this over, move it over 1, and 1 should facing the anode pin of the LED. So it comes out of the LED to the resistor, from the resistor to this track where I'm tapped into it there. So now each one of those are tapped in correctly. So we have 3 of them connected so far. Let's continue. We're going to find pin 7. So pin 7 should be here. I'm going to find pin 7. That's going to be LED number 4. Yeah. Then we are going to find pin number 10. That's 8, 9, 10. So pin 10 is here. That's going to be LED 5. Then we'll find pin number 1, which is back to the top of this guy here. That's going to feed LED 6. Then we would find pin 5. I think it's here. I believe. I hope so. 6. Yep. And then we'll have that feed the 1, 2, 3, 4, 5, 6, 7 one. Okay. Then pin 6 of the chip, which is next to that 5, is going to feed just the next LED. Then I want to, for the 8 LED, I'm going to use pin 9. Well, let me see. Yeah, pin 9 is here. Pin 9 would feed this one. And then our final LED would get a feed from pin 11. Let me see if I have a wire long enough for that. Let me see here. So that's 8, 9, 10, and 11. So I'm going to put it here and just there. So right now, I was going to double check and make sure the wires, these wires here coming from the IC chip, are in the right hole. I'm just double looking here. It's in there, it's in there, and there. Okay, so far we have the output of this 407 tied to the LEDs like they want. Then we're going to send some energy to the negative. Pins 8, 15, and 13 have to go to ground. So we're going to put pins 8. First, I'm going to find how to get in there. I'm going to put pin 8. So that's in there. Yep, I'm going to put that to ground. I think I use the ground on this side of the track since it's kind of close proximity. I'll use the ground there. So pin 8 is in ground. I want pins 15 also in ground. So we will find that. That's up here. Since it's a 16 pin chip, this is pin 15. And we'll send that to ground as well. Then we have pin 13. 8, 9, 10, 11, 12, 13. So 13 also gets grounded. Well, I should use a different color for a minute. Let's see, 9, 10, 11, 12, 13, right here. And that's going to get grounded right there. So far we have pins 8, 15, and 13 going to ground. Pin 14 is going to get a feed from pin 3 of that 555. So I'm going to find pin 14, which is here. And I want to send that to the output clock pin of pin 3, which is the clock pin. So now we have this. We get the clock pin going to pin 14. That's hooked up. Next, we're going to let me see here. Pin 16 can be going to get a positive lead. So we're going to put a positive piece on there. I'm going to use the orange one here. So pin 16, we'll put that on the positive rail. That's just a rail right next to the negative. So that's hooked in. So pin 16 is getting positive energy. Let's see here. And we're going to go back over pins 8, 15, and 13 are negative. 3, 2, 4, 7, 10, 1, 5, 6, 9, 11. All of these are feeding the LEDs here. I had to bend these sort of kind of strangely, like, sorry about the camera hitting me there, okay, to fit these in the board. As you notice, I had to angle those pins. That's why I didn't want to bring you in on that, because it was time consuming to get those just like I wanted. And it was going to take up too much recording time to do that. So I just did them ahead of time. That's why you didn't see me. But I had to bend each one of these that way and to get them in the board. Okay, so now essentially the 4017 has all its wires going where it's got to go. The positive lead, which is pin 16, is getting its feed here. The negative lead, which is pin 1, should be getting its feed. But let me double check that though. I don't see one going there, so I'm going to find out that's about, let's see, I got pins 8 with the 1. I need pin 1 also needs negative. So pin 1 is, let me look here just a minute. No, 1 is going there. I'm sorry, that ain't where that ought to go. Let me take a look here. I'm going to the cathode. I mean anode then to the cathode. Got that. I'm just double looking at something here just to be certain. No, so we don't need to do that. Pin 1 is not going to be a negative pin. It's going to a LED. So that's fine. We're going to finish hooking up the 555 timer chip in astable mode. Right now, all I got hooked on it is just the output clock pin. So I need to finish wiring that up. I'm going to use a 100 microfarad capacitor. And we're going to go from pins 1 to 2. And that's going to be here. So the negative of the electrolytic capacitor is in pin 1. Let me put you back in the camera there. Sorry about that. Then we have the, I'm using a 1000 ohm resistor, 2 of them. I got a brown, black, red here. I'm going to, that's going to go in pin 6, 7, and 7 and 8. So 6 and 7, and then 7 and 8. And that's going to give it its circuitry that it needs to fire automatically. And now I'm trying to see if I got, okay, pins 1 of the 555 needs to go to ground. So pins 1 here, then we put that to ground, which is the outer track. With this type of circuit, it really requires a printed circuitry board, but to hardwire it on a prototyping board is rather tedious because you can't really see everything because of the so many lines running all over the place, but it's doable. Okay, I got my 555 timer. Let's just double check that out. 2 to 6, 4 to 8. We have the control resistors. We have the capacitor. Pin out. Pin 1 going to ground. Pin 8 going to positive. Pin 5, we don't do nothing with that. And I believe that's it. I believe that's everything. Now, if this circuit works, the light should show. It looks like the light is chasing each other. It's going to go. It should continue on its own. Okay, let's give it a shot and see if this works. I'll move this out the way. And I'm going to bring in some voltage here. I have a power cell again. This is 3.7 volts at 4200 milliamp. So I'm going to use that as a power cell. Let me see if I got a positive lead. Sorry about that. The camera kind of timed out on me. That's why I was trying to hurry. Okay, we're back. So I'm hooking up the power to this circuitry now. We're going to test it and see if it works. I got the positive here. I'm going to hook that onto the positive line, positive track. And I'm going to hook up the negative end on the negative track here. Let me just plug that in. Now I'm going to hook that to the back. When I touch this, it should, if it works, it should fire. Oh, it does. Okay, so I'm going to hook that in. So I just want to be sure that wasn't going to do anything else. And there we have it. It is a LED chaser, essentially. The decade counter that we were showing in here in this circuit. Decade counter that we were showing here is was counting in counts of 5. And every time it gets a pulse, it moves on to the next LED. And that's what you're seeing happen here. You can change the speed of this light by changing the clock pulses speed. And the way you can do that is we'll stop the power for a second. We'll cut the power off. I'm going to remove this capacitor on this 555 timer and put in a smaller one. I'm going to put in a 22 microfarad. And let's see how fast it can go. And if my camera can keep up with it. Let's see. Alright. Let's give it a shot. And on. Oh, that's a little faster. I don't know how it's coming across on the screen, but I hope you can see that rate of flashes. So that's essentially it. The decade counter causes every time it gets a pulse, it moves the energy to the next pin. And these are all, like I said, current limiting resistors in this row, which I don't know if you can see. Yeah, current limiting resistors in this row. And each time a pulse comes across, the next LED gets its energy. And it'll continue that until the power is disconnected. I hope you enjoyed this little demonstration of the 555 and the 401 decade counter IC chip. And if you can, hit that subscribe button. I don't know where it is. I think it's down there or up there. I don't know. But hit that subscribe button and give me a comment if what you want to see. If you want to see other circuits built. And until next time, have a nice day. Bye.